So this video is for task 4. This is a second example of a linear programming problem. Suppose Max is baking cookies and muffins for a bake sale. Each tray of cookies uses 5 cups of flour and 3 cups of sugar. Each tray of muffins uses 5 cups of flour and 1 cup of sugar. He has 40 cups of flour and 18 cups of sugar available for baking. He's going to make a profit of $12 for each tray of cookies and $8 for each tray of muffins. How many trays of cookies and trays of muffins should Max bake to maximize his profit? And what will be his total profit? So let's go through our steps. First of all, what do we have to find the number of? In this case, we have to figure out how many trays of cookies is Max going to make, and how many trays of muffins. So I'm going to let X equal the number of trays of cookies. I'm going to let Y be for the trays of muffins. Step 2, I need to write my system of inequalities. So what is going to limit how many trays of cookies and trays of muffins Max can make? Well, he only has so much flour and so much sugar. So each tray of cookies uses 5 cups of flour. So I'm going to take 5 times the number of trays of cookies plus what he has to use for the muffins, which is another 5 cups of flour for each tray of muffins. Now he only has 40 cups of flour. That's all he's got. He doesn't have any more flour. So the 5x plus 5y, that's going to have to be less than or equal to 40. He also only has so much sugar. He needs 3 cups of sugar for each tray of cookies and just 1 cup of sugar for each tray of muffins. And he has a total of 18 cups of sugar. So 3x plus 1y has to be less than or equal to 18 because he can't use any more than 18 cups. Now, there are actually 2 more inequalities, but they're actually not listed in this problem. They're ones that we have to consider because of this situation we're talking about. Think about what type of number x and y can be. Could Max make -3 trays of cookies or -4 trays of muffins? No, that doesn't make sense. And so we need 2 more inequalities. We need x is greater than or equal to 0 because he has to make more than or equal to 0 trays of cookies. And the same thing for muffins. That has to be greater than or equal to muffins. It could be equal to 0 because it may make sense for him to make no cookies and make only muffins, or vice versa. So there's my system of inequalities. I'm going to go ahead and graph these, but first if we look at our slope-intercept form for these first 2, because that's what I want to do. I want to look at the slope-intercept form to determine the scale of my graph. The first equation, or first inequality, keep calling it an equation, sorry, is going to come out to be y is less than or equal to -x plus 8. And the second one comes out to be y is less than or equal to -3x plus 18. Now, this is actually a pretty big graph. There's a lot of room here. I don't even think we need to change the scale. But if you were going to, if we look at the numbers 8 and 18, what number divides into both of those numbers evenly? You might say 2. So what you could do is change your scale on each graph to go up by 2s. In this case, I'm not going to change the scale. I'm pretty sure I can fit everything in here with everything just being as it is. So I'm going to graph the top one. Y is less than or equal to negative x plus 8. Try to get close here. My slope is -1. Having some problems making some points on here for you all. Down 1 over 1. This graph is really tiny. I don't think I'm doing a very good job here. We get a somewhat of an idea there. Second one, let's grab a different color. Slope is down 3 over 1. Hopefully you can take a little bit more time and get a better graph than I've got here. And we can't forget about our other two inequalities. We want x to be greater than or equal to 0. We want y to be greater than or equal to 0. So our shaded region ends up being right down here in this corner. It's kind of a four-sided figure. Back to step 4. My objective function, my vertices, 0, 0. That one really doesn't make sense. It doesn't make sense for him to make no cookies or muffins because he's not going to maximize his profit that way. But it is a vertex. We have one at 6, 0, 0, 8. And we have one at 5, 3. Step 5, we need that objective function. Again, we're talking about profit, so I'm going to use a P. $12 for each tray of cookies, $8 for each tray of muffins. If we plug those in for step 6, again, because of the length of this video, I'm going to sort of skip some of these vertices. If we check 5, 3, you do need to check all of them. If I check all of them, 0, 0 is going to give me 0. 6, 0 would give me a profit of 72. 0, 8 gives me a profit of 64. But 5, 3 gives me a profit of $84. And so to answer the question, how many trays of cookies and muffins should he make? 5 trays of cookies and 3 trays of muffins to earn a maximum profit of $84. And that's example 2 of task 4.